Okay, so this is continuing the review for Math 3 Unit 1, starting with question number 19. So this one right here is I'm looking to restrict the domain, and I know that because of the inequality interval for the function f of x equals 3x. So the part I'm going to focus on first is I want to just graph what does that look like. So I'm going to rewrite that as y equals 3x, and I'm just ignoring the inequality for right now. So I have to find my start. Not adding anything to x, and I'm not adding anything to 3x, so my start is 0, 0. And then my slope or my stretch is just the number multiplying x, which is 3. So from my start, I'm going to go up 3 and over 1. And then because it's a line, I'm going to go down 3 and left 1. So normally I would just draw in that line and connect the 3 dots and be done. But now this is telling me, though, I only want to graph the part where x is between -1 and between 2. So I only want the part of the graph between -1 and 2. And I want to be precise, but I can look here at -1, that I have that dot already in place, and it should be an open circle because it's not equal. But then at 2, I've got no indicator here on where to connect to. So all I'm going to do is replace x with 2. So then that would be 3 times 2, which is 6. So that means when x is 2, because that's the number I substituted it in, my y value is the result, which is 6. So over 2, and then up 6, and it's a closed dot. So that means I'm starting at -1, and I'm going until I get to 2. And then I just connect. Okay, so there's 19. Okay, let's flip the page to 21. Okay. So for question number 21, I've got a pieced function. So what I want to do is I want to graph these separate from each other. So this is my first equation, just y is equal to 2. So my start on this doesn't exist because it's just a line. There's no value for x, so there's no shifting going on. I don't have a stretch, right, because I'm not having an x to multiply by. So I don't have a start, and I don't have a stretch. My split is at 0. I don't have an x to substitute into, so my y value would just be 2. So normally, this equation would just graph, I would go to where y equals 2, and I would normally just draw a horizontal line here. But then I'm splitting the graph at 0, 2. It's not equal, so there's an open circle here. And I want only the section, so I have two choices, right? I either want the left half or the right half. And I want the left half because it's less than, so that means I want this part right here. So I'm just going to extend it and darken it, and then I don't want this piece here. Okay, I'm doing the same thing for the next one. So this is a graph of a line, because there's no squared, no absolute value, and x is not in a power. So it's just looking for a line. So my start, x is not grouped with any x value, so that would be a 0, right? No parentheses. And then my vertical stretch would be 2. And I got that from right there. My stretch is a number multiplying x, which is -1. I want to find where the split is. So same thing as I did above. I have to take the 0 and replace it in for x. So then that would be -0 plus 2. So that would be 0 plus 2, or 2. So it's the same place and equal. So over 0 up 2. So that means this will now fill in. Okay. And then now I need to graph. So this is just a line with a slope of -1. So that means I need to go to this way because it's greater than. So I'm going to go down 1 over 1, and one more time down 1 over 1. 1, and then just draw that in. Okay, let's do the next one. Let me separate this out some room. Okay, so this is 22. So at my start, my stretch, and my split. So my start here is at 1. Nothing added, so 0. My stretch is a number multiplying, which is just a 1. My split is at 3. And then substitute 3 in. So 3 minus 1 is 2, squared is 4. Okay, so let's go ahead and graph that one. So we're graphing just one at a time. So I go to my start, over 1, up 0. My stretch is 1. So this is squared, so it's going to be a parabola. So I'm going to go up 1, over 1, up 1, other way. I have to graph this point as well. So 3, 4, 1, 2, 3, 1, 2, 3, 4, and it's an open circle because not equal. So now what I have to do, so normally this graph would look like this, right? I have to pick what side of the dot I want to actually keep. Do I want to keep this little piece here or keep all of this? And I look here, and this says I have to choose the values of x less than 3. So here's 3. So that means I want to keep going that way, right? That's smaller numbers. So from here, will I catch that by going up or by going to the left and down? Going this way. So I'm going to keep this part. And erase this part. Okay. All right. Do the next one. So for my start, there is nothing in with the x, so that would be 0, and then -1. My stretch is the number multiplying. My split is here at 3, and put 3 in for x, so the absolute value of 3 is 3, minus 1 is 2. So now I'm going to graph it, so I go over 0, down 1. My stretch is 1, up 1 over 1, up 1 over 1. So normally this would be a V shape, right? And I've got to go to 3, 2, so 1, 2, 3, 1, 2, and it's also an open circle. Okay, so then now I have to graph the part that is greater than 3. So here's 3, to go to greater than 3, I'm going to go that way. So I'm not even going to connect these dots anywhere because of the way my graph goes. So I'm just going to go greater than 3, keeping my stretch of 1, so up 1 over 1. I know I'm covering it, sorry. So I'm keeping my stretch of up 1 over 1. So there's my graph. And then I just realized I forgot domain and range. So I'm going to backtrack here. Go back to 21. Let's do domain and range. So domain, forever to the left. This is going down, but also to the right. So forever to the right. My range, bottom to top. So this is pointed downwards forever, right? So I can imagine this is going downwards forever. So bottom value is negative infinity because it doesn't stop going down. So my bottom is negative infinity. And then if I go upwards, it looks like it does not go above this line here, right? There's no graphing up here, and this isn't curling up, just say there's more. So that was at 1, 2. So my highest value is 2. Okay, domain and range on 22. So for the domain, forever to the left, forever to the right. But you see how these have open dots here? That means I can't actually equal 3. So yes, I'm going forever to the left, but when I go to the right, I have to stop at 3. And I can't include it because of the open dot. Right? So it stops here at 3, not equaling 3. And then we pick up again over here, again at 3, and then forever to the right. All right, for the range, bottom to top. So there's no graph down here at all. In fact, the bottom looks like right here at 0, including 0. And then this portion of the graph covers every y value going upwards forever. So I'm just going to use that section and call that infinity. I wouldn't go here because that stops, but this one is also going up, going up. So even though there's open dots and weird stuff going on here, this portion covers every positive value of y going this direction. So that is good for there. Okay, let's do the next one. So this one I have to do 3 graphs for. So I'm going to try to do this without doing all the start, stretch, split, and just work through it, okay? So I know my start is 0, 0, nothing added or subtracted anywhere. My stretch is 1/2, so I'm going to go up 1/2 over 1. And if I want to do one more dot for accuracy, I can. So if I substitute 2 in, 2 squared is 4, 1/2 of 4 is 2, and then symmetry. So here is my 0, so I'm going to where x is 0, which is right here. I'm going to darken it because it is equal, and I want to use the values less than 0. So that's going to be this portion because that's where I'm smaller than 0. So for this here, just a numerical value, so that means it's just going to be a horizontal line through 1. So normally it would be this whole line, right? But I want to start at 0, and it's an open dot, and I want to go until I get to 3. So 1, 2, 3, and then it's a closed dot. Okay? All right, now we have to do this one. So normally this graph would be shifted right 3, so 1, 2, 3, right? Because of the -3, so my start would be at 3, 0. My lower bound or asymptote would go right here. So there's my start at 3. And then I would go up 1, and normally it would be an open dot that's already closed, so that's good for us. And then my stretch is 2, so up 2 over 1. And then I want to be greater than 3. So normally I would do these 2 dots here and swoop through, right? Make kind of a J graph. But then it's just going to, I'm covering it again, so it's just starting here and then going off to the right. Okay. All right, let's do domain and range. Forever to the left. Forever to the right. Now there's an open dot here, but a closed dot underneath it, so that's okay. And then for my range, bottom. So normally for lower bound, this would not include, but this dot on this graph works, so we would include the 0. And then this portion just by itself goes up forever, so that would be to infinity. Okay. Next section. Okay, again, I'm going to try to graph this without doing the start, stretch, and split. So this is 3. So normally I would just go to 3 where y equals 3 and just draw a straight line. But I'm only using the part where I'm less than -3. So I'm going to go to -3. It's an open circle, so at -3, 3. And I'm using the part smaller than -3, so that would be to here. Okay, for this graph here, x squared minus 2, so my start is at 0, -2, with a stretch of 1. Now I have 2 values I have to pay attention to. So first I'm going to replace -3 in. So square that is 9, minus 2 is 7. So at -3 and then up to 7. And it's a closed dot. So again, just 3 squared 9 minus 2 is 7. Do the same thing for 2, so this is closed. 2 squared is 4, minus 2 is 2. So over 2, up 2, also closed. So I'm graphing the portion between -3 and 2 of my parabola. So I need to draw my parabola. So something like that. And finally this one here. So this is just a line y equals x, so my start is 0, 0 with a slope of 1, so up 1 over 1. So normally it would be just, you know, this little portion right here, but I only want the part between 2 and 5. So I'm going to replace 2 in here, so when x is 2, my y value is 2. So it would be this. Normally it would be an open dot, but it was closed from the previous graph. Do the same thing for 5. So 1, 2, 3, 4, 5. Put 5 in for x is 5 again. 1, 2, 3, 4, 5, and an open circle. So I would just connect these two lines here. Okay. All right, so let's do domain and range. So for my domain, I've got forever to the left. And then when I come over here, I have an open dot here, but there's a closed dot above it, so that's good. Then it's still covering ground, and then it just stops all of a sudden. And where did it stop? It stopped at 5. And it's not closed, so it would be parentheses are exclusive. Okay, range. So it's not forever bottom. There's my bottom, so that's at -2. And this portion looks like it covers most everything, so I'm going to use this part right here, which stopped at 7 and equaled. Okay, not a lot of infinities on that. All right, so let's look at how do we write equations. So when we're writing equations, we're just trying to say, okay, well, what kind of graphs do I have here? So I have to kind of picture, well, what pieces of what graphs am I looking at? So I know that this is just a line. There's no V shape, there's no curve to it, looks like just a line. And this portion right here, if I were to continue, it kind of looks like my parabola. So this part is a parabola. So then I just need to come up with those two equations. Okay. So let's do my line first. So I can pick any dot, so I'm going to call that my start. Which is at, what, -4, 2. And then that'll be my HK. And then for my slope, see, rise over run, so there's 2, let's see, 4. So then my slope, rise over run, would be 2 over 4, or 1/2. So I'm just counting, so up 2 over 4. Okay. So for my line, y minus k equals 1/2, and then x minus -4. Now if you used 0, 4, you would have these numbers different, right? So then I'm going to add the 2 over. And the double negative will be a plus. And so there's my first equation. Oops, I covered all that, didn't I? Okay. So now for my parabola, I'm going to do the same thing again. So for the parabola, let's see. It's kind of hard to tell. Okay, so the vertex looks like it's at 2, 5. And we'll use this point over here, 0, 4. So this one, if I look at my stretch, I'm going down 1, but then I'm going over 2. So because it's over 2 and not over 1, I have to solve for it. So I'm going to scoot over here so I have room. So just a reminder, so my vertex was 2, 5, and I'm looking over here, and my other point was 0, 4. So this is my vertex H and K, and then there's my point 0, 4. So y minus k equals a, x minus h squared. And then now I have to solve for y. So in order to solve for y, or excuse me, a, I need to replace x and y. So I'm going to put 4 minus 5, so replace y with 4, and then replace x with 0. 4 minus 5 is negative 1, and then this is negative 2 squared, which is positive 4. So 4 times a is the same as 4a, and then divide by 4. So I'm running out of room here. Okay, so I have back to this equation, and then I'm just going to replace my a with negative 1/4. Okay, and then I'm going to add my 5 over to the other side. Okay, so I kind of have everything everywhere. All right, so here's my two equations. So I've got my line and I have my parabola. So that's going to be the portion for my f of x. So I'm going to squeeze that in here. So my line first. And then I'm going to put my parabola under that because that came second. Okay. Now I just have to look over here to see, well, how far do each of these go? So I'm going to look over here. So the parabola, or excuse me, the line started at negative 4 and then stopped at 0. So negative 4 to 0. So we got to remember that. So from negative 4 to 0. And it was solid there, solid there. Okay. And then, so the parabola then had to have started at 0, and it can't equal both at the same time. I guess it could. And then ended here at the 6, so squeeze in a 6. There you go. So that was squished in there. So from 0 to 6, because I'm just looking here, started at 0, ended at 6. And then started at negative 4, ended at 0. And that's where I got those two numbers from. Okay, zoom out just a little bit. That's better. So from negative 4 to 0, and 0 to 6. Okay? All right, and now this one. So I have 3 sections I'm looking at, just the straight line. So that one's easy because that's just going through 2, so y equals 2. This is a parabola, so I'm going to have to do something with that, and that looks like an absolute value. So let's do the parabola first. So it looks like my vertex is at 2, 0. And I think my stretch is going to be a whole number here, which is nice. So I'm going up 2, and I'm only going over 1. So because I'm only going over 1, my stretch is easy. So that means my a is 2. So there's hk, and a would be 2. So then that's for my parabola. So let's write that equation out. So y minus k equals a x minus h squared. So we really need to get those memorized, because otherwise what I'm saying makes no sense. Y minus 0 is just the same as y. So this one's going a lot faster. So I've got 2 equations, right, already, out of 3. So 1 more left. So my vertex, so let's see, looks like it's at 5, 3. So 5, 3. So there's hk, absolute value. And then for my slope, I'm just going to count. So let's see. Looks like we're going down 1 and over 2. And it's negative, so it should be negative there. So absolute value, y minus k, equals my slope, which is negative 1/2. And then x minus h. And then I need to add the 3, add the 3. All right, so I've got 3 equations, and now I need to write these out into the f of x piece function form. So here's my 3. So I have f of x. I'm going to go left to right. So y equals 2. Then my parabola. And then my absolute value. Okay. So those, now I just need to do my inequalities. So for this one here, it looks like I started at -4 and ended at 1. So -4 to 1. Move that over just a little bit. And then for my parabola, I started at 1 and ended at 3. And I started at 3 and stopped here at 9. It's tough to see. Okay? All right, next page. Oops. Okay, next page. All right, 27. Okay, so graph the function below and describe the transformation. And so I'm just going to graph this one first. My start is at 2, 3, so over 2, up 3. My stretch is 1. So now I also have to graph this one here. So my x value is negative or opposite. So any x values that are over here are going to go opposite, so over here. So that means it's going to reflect over here. So instead of going right 2, I'm actually going to go left 2 and up 3 with the same stretch. And then I'm going to use a dotted line to describe or to distinguish. So this was my original, and this was my changed or transformed. So then it says I have to describe it. So this was a reflection. So I would say it reflects along the y-axis because it moved across the y, so over to the side. So it's just a mirror image of itself. Okay, 28. So my start is at -4 and -2. I have a stretch of -1/2, so down 1 over 2. So that's g. So this is -g of x. So x is not negative, right? X is not negative. So my x's are not going to go opposite. Remember, this means y, so that's -y. So that means my y values are going to be opposite. Anything that's negative will turn positive. So that means it's going to reflect, but mirror up into the x, or along the x. So instead of being down here at 2, it's actually going to go up here at 2. Same stretch. Up 1 though, over 2, up 1 over 2. Just so it reflects. I'm going to use a dotted line to distinguish. And so then that would be -g of x. Okay. All right, number 29. So again, so my start, so x plus 1, so that would be -1, and then down 3, 1, 2, 3. So my start would be -1, -3, and then this is exponential, so this will have a lower bound, and so that's what I just found here was where my lower bound or asymptote is. And then my stretch is 2, so I'm going to go up 2 over 1, and I need one more. And graph that. Okay. And now this one is, I want my y value to be shifted up 4. So that means everything needs to go up 4. I'm going to use a different color for this one just because of the asymptote. So I'm going to move this guy up 4. So 1, 2, 3, 4. Okay, so, and then this will go up 4. And up 4. And so for description, I would just say up 4. Okay. All right, so this one is going to be a line. I know it's a line because there's no squared, no absolute value, and this is not in the power. So I'm going to do my start, which is at 4 and -2. So 4, -2 is my start. My stretch is 3, so up 3 over 1 and down 3, left 1. Probably should use a straight edge there. Okay. So now for this one here, I'm going to go left 3, right? I'm going to go left 3. So everything's going to move left 3. So I'm just counting. So 1, 2, 3. And it'll have the same slope. So up 3 over 1, down 3 over 1. And then I'll do a dotted line. Not very straight. So this was G. And this one was the x plus 3. So this one went left 3. Okay. All right. Oh, getting there, right? All right, 31. So this one, all we're doing is we're graphing two things here, right? We just have two things to graph. And it's no different than all of the graphs that we've been doing. Find your start, what's your stretch, that whole thing there. Okay, so let's do that. So my start would be at -2, -1, and my stretch would be 3. So up 3 over 1, up 3 over 1. I know it's a parabola because of the squared. So this one here. So this one I'm going to go, my start is at -4, +2. And my stretch is -3. So I went -4, +2, and then down 3 over 1. And that would be g of x. So now I have to explain what happened to go from F to G. So to go from F to G, I'm just going to count vertex to vertex. So I went 1, 2, 1, 2, 3. So left 2, up 3. So I went left 2, up 3. So left 2, 1, 2, up 3, 1, 2, 3. And then I also reflected because it points a different direction. Okay. And next one. So my start here is at 0 because there's nothing in here, and 3. I have a slope of -1, so down 1 over 1, down 1 over 1. It's absolute value graph. And then I'm going to label that, so that's f of x, and now do g of x. So my start is -1, -2, and my slope is 1, so up 1 over 1. And there's g of x. So I know I'm doing the graphing fast, but hopefully at this point the graphing piece is okay for you. And if you're struggling with that, then you should look at the first video where I hopefully did the graphing a little bit slower. So then now to figure out what I did, I'm just going to go from F to G, and I'm going to count for vertex. I'm just counting to go from here to here and see how much I moved. So I went 1, 2, 3, 4, 5 down, so 5 down and 1 left. So down 5 and left 1, and it also reflected because it's pointed the reverse direction. Okay. Okay, so for this one right here, they're asking us to, for each of the following intervals, state whether it represents, whoops, you can't see that, can you? State whether it represents a linear function, which is just our line, a linear absolute value function, or quadratic. So the absolute value is our b, quadratic is our parabola. So if we look from -4 to -2, that's just our parabola. So that means this is a quadratic. So if I look from -2 to 3, so this part right here, what shape is that? Is that going to be a line, an absolute value, or is it going to be a quadratic? In this case, it's a linear absolute value. I know we haven't seen this piece about it where it says linear. Linear just means you have lines for your sides. Normally, we've just always been calling it an absolute value function. And then finally, from 3 to 5, this part right here, that's just a quadratic, just like the first part was. So quadratic. Okay, that one was easy. All right, 34. So when we look at this, we have our function is comprised of 2 different equations. And so that means I have to decide, well, what equation am I going to be using? And how I make that decision is based on this inequality here. So they want me to replace x with 3. So I have to look, well, is 3 smaller than 2 or is 3 bigger than 2? So I know that 3 is bigger than 2, so I need to be using this equation for this problem. And I'm not going to use that. So instead of a x, I'm going to replace it with 3. So I have 1 minus 3, replace my x, and then squared. And then I just need to work that out. So that would be 1 minus, and then this would be 3 times 9, and then that's just negative 26. Okay, so now that's done. Okay, so let me erase this. So I'm looking at it all fresh and new, because now I'm going down to part B. So now I have to replace x with 2, and again I have 2 equations to pick from. So 2 is actually where it's splitting, but only one of these is where it's actually equal, and that's this one because of the bar under it. So that means this is the equation I'm going to use when x is 2. So now I use this equation, and wherever I see the x, I replace it with 2. So 2 to the power of 2 plus 1. So replaced x with 2. So 2 squared is 4 plus 1, which is 5. Okay, and now I do it again. And now I do it for 0. So I'm going to erase because I'm starting a new problem. So now 0. So is 0 less than 2 or is 0 greater than 2? 0 is less than 2, so then I'm going to use this equation. So do the same thing, but instead of x, I'm going to use 0. And everything else stays the same. So 2 to the 0 power is 1, and then plus 1 is 2. So 35 through 39 is the same idea, or excuse me, 35 is the same kind of idea as what we just did for 34, but we're just selecting which statements are true. So we're seeing, did they use the right equation for the right problem? So for 3, I decide which equation is the correct one. Should I use the top one or the bottom one? So is 3 less than 0 or greater than 0? Well, 3 is greater than 0, so this is the equation I'm going to use for this problem. So I'm going to replace x with 3, and then work that out. So 3 minus 1 is 2. So that would be negative 4 plus 3, which is negative 1. So that statement is true, so that's true, because I got negative 1. Now let's do the next one. So for this one here, we're going to replace x with 2. So is 2 smaller than 0? And then is 2 greater than 0? So 2 is greater than 0, so I'm going to use this equation here. And so then I'm going to just replace x with 2 again. So I'm doing the same thing again, but this time replacing x with 2 instead of 3. 2 minus 1 is 1. So that would be negative 2 plus 3, which is 1. And they got 6, so they're wrong, so I won't choose that one. Okay. Same thing again here. So 0. So this time I want to pick where it's equal, so that's going to be this one because of the line. So now I'm going to replace x with 0. So 0 minus 1 is negative 1. That's going to turn positive, right, because of absolute value. So negative 2 times 1, and negative 2 plus 3. And they got a 2, not a 1, so they're wrong. Okay. All right, and we just did that. So 0 was 1, so that's right. And finally the last one, negative 2. So negative 2 is smaller than 0, so then I'm going to use this equation. Negative 2 is smaller than 0. So instead of x squared plus 2, I'm going to put an x replaced with negative 2. So negative 2 squared is 4, and 4 plus 2 is 6, and they got negative 2, so that one's wrong. So A and D were the only two that are true. Okay, last page. All right, so this is just multiple choice, so select all the statements that represent the graph below. So if I look here, my vertex is at 0, negative 1. So that means it can't be this one because they're showing a shift of 1, 0. Okay, this one's right, 0, negative 1. So if it's minus 1, then that can't be right. And this one also is right, isn't it? So 0 and negative 1. And so now this one we may not, you guys can't see anything I'm doing, I just realized. I'm sorry. Okay, let's try this again. Okay, so my vertex was 0, negative 1. So 0, negative 1. So this one has a start of 1, 0. So I know it's not that one. This one, there's nothing in parentheses, so it has a start of 0, negative 1. So that one's right. This one's a plus 1, so that can't be. And then this one has a start of 0 and then negative 1, so that one's good also. And you might not actually know this one, but this one is right as well. So you might have learned like factoring this, so difference of squares. So x squared minus 1 does factor to that. So D is actually a true answer as well, just kind of a sneaky one. So if you didn't get that one right, that's okay. All right, and then let's take a look at 37. So for 37, this is a restricted graph. I could tell because it has a start and a stop, and then also they have this inequality here. So if I look, it starts at negative 2 and then stops at at 3. So I already know it can't be this one or this one because negative 2 to 3 all the way down. So my vertex, if I look here, is at negative 1, 1, 2, negative 1, 2. So my start here is at negative 1, negative 2, so it can't be that one either. My start here is at negative 1, 2, and positive 1, negative 2, so it's not that one, so that would be D. Okay. All right, very, very last one. All right. So let's see, my vertex is at 1, 3. So here my vertex is -1. So let's get rid of all the plus ones. Oh, let's get rid of these here because this is saying at 3. These have these flip-flopped. That was kind of sneaky. So they put the 3, do you see that, in with the x instead. So we don't want to do that. So we're torn here. So that would be +1, -3. So it's not that. +1, +3. And that, my friends, is the whole review.